Have you ever wondered why the earth sometimes breathes fire? It's a strange thought, isn't it? That the very ground beneath us can wake, that stone can melt, that mountains can suddenly come alive. And yet, this is the quiet truth of our planet. Beneath its calm surface, it is never truly still. Volcanoes are the Earth's heartbeat, slow, deep, and ancient. They remind us that our world is alive, not merely a rock floating in space, but a restless, breathing organism made of heat and movement. Each eruption, each glowing river of lava, is a message from the planet's interior, a fiery whisper saying, "I am still here." When you think about it, that's quite comforting. The Earth isn't fragile, it's powerful, dynamic, even creative. Volcanoes, after all, are not only destroyers, they are builders too. Every island in the Pacific, every fertile valley in Italy, every grain of volcanic soil beneath a vineyard owes its existence to these glowing furnaces of creation. The story of volcanoes begins deep below your feet, in a place you'll never see, at least not directly. The Earth's interior is layered like a vast, cosmic onion. At the very center lies the core, mostly iron and nickel, as hot as the surface of the sun. Surrounding it is the mantle, a sea of rock so dense and hot that it flows very slowly, like thick honey. Above that, floating like a cracked eggshell, lies the crust, the thin outer skin on which we live. It's thinner than you might think. If the Earth were an apple, the crust would be no thicker than its peel. This crust isn't one continuous sheet. It's broken into enormous plates, like puzzle pieces drifting across the mantle. These are the tectonic plates, and they move because the mantle beneath them stirs, heat rising, rock flowing, the planet slowly breathing. Where those plates meet, things get interesting. They collide, slide past one another, or pull apart. And in those margins of contact, the Earth finds a way to release its pressure. That's where volcanoes are born. At a divergent boundary, plates drift apart. Imagine two rafts slowly separating on a vast lake of molten rock. As they move, magma, melted rock from the mantle, rises to fill the gap. It cools, solidifies, and forms new crust. Most of this happens quietly beneath the ocean, creating ridges thousands of kilometers long. You might never notice, but right now, as you listen, the Earth is building new seafloor somewhere deep beneath the Atlantic. At a convergent boundary, the opposite happens. One plate dives beneath another in a process called subduction. As it sinks, it melts, releasing magma that rises toward the surface. When it finds a crack, pressure builds, until eventually, the Earth exhales in fire. That's how many of the world's great volcanoes were born. The Andes, the Japanese archipelago, the fiery ring that circles the Pacific. It's called the Ring of Fire. A dramatic name, but not inaccurate. Nearly 75% of all active volcanoes lie along its path. And then there are the hot spots, mysterious places where plumes of molten rock rise straight from deep within the mantle, punching through the crust wherever they can. These are the Earth's freckles, isolated, independent, creating chains of islands as the tectonic plate drifts above them. Hawaii is the most famous example. Each island in the Hawaiian chain is like a frozen footprint of the same moving plate, a timeline of eruptions stretching back millions of years. Kauai, the oldest island, is weathered and green. The Big Island, youngest and still growing, glows with fresh lava at its edges. It's the Earth's slow-motion handwriting, one molten syllable at a time. Let's talk about magma, the fiery heart of the volcano. Magma is simply molten rock that forms when parts of the mantle melt. When it erupts onto the surface, it's called lava. It's a small distinction, but an important one. Magma is the promise. Lava is the performance. Depending on its composition, lava behaves differently. If it's rich in silica, the same material that makes glass, it's thick and sticky like honey on a cold morning. It moves slowly, traps gases, and tends to explode dramatically when it finally escapes. Those are the eruptions you've seen in photographs. Ash plumes, glowing clouds, thunderous bursts. If lava has less silica, it's runny, fluid, and flows easily across the land in long, glowing rivers. These eruptions are gentler, though still powerful, a kind of slow dance between rock and fire. The Hawaiian volcanoes are like that. Patient artists, painting the landscape with molten light. People often ask, what makes a volcano active or dormant or extinct? The answer is simpler than it sounds. It's a matter of timing. An active volcano is one that has erupted in recent history and still shows signs of life, tremors, gas emissions, or heat. A dormant volcano is one that's sleeping, quiet for centuries perhaps, but still capable of waking. And an extinct volcano is one that has burned out completely, its magma source cut off, its chambers cold. Even then, extinct is a cautious word. Geology operates on a scale of millions of years. To us, a volcano might seem dead. To the Earth, it might just be thinking. Volcanoes are storytellers of deep time. They remind us that the ground we stand on is temporary, that continents drift and mountains breathe. Every pebble, every grain of sand, was once part of a story written in heat. It's humbling and oddly comforting. To live on Earth is to live on a planet that renews itself, sometimes violently, but always with purpose. And yet, we've learned to live with them. People build homes on their slopes, vineyards in their ashes, cities in their shadows. Why? Because volcanic soil is among the richest on Earth. When lava weathers, it releases minerals, iron, magnesium, potassium, that feed plants and turn gray fields into green paradise. Naples, sitting near Mount Vesuvius, thrives on the fertility of ancient destruction. Java, in Indonesia, grows rice on the shoulders of volcanoes that still smoke. It's a strange bargain, danger traded for abundance. But it's one humanity has made for thousands of years. Perhaps that's what makes volcanoes so hypnotic. They embody the paradox of nature, creation through chaos. They destroy, but also renew. They terrify, yet sustain. When you watch a volcano erupt, you are seeing the Earth reinvent itself in real time. It's violent, yes, but also strangely serene, like a storm that knows exactly what it's doing. And if you listen carefully, not to the explosion, but to the silence that follows, you might hear what geologists sometimes call the deep hum. It's the vibration of magma moving, a sound too low for our ears, but one the planet never stops making. That hum is the rhythm of our world. Slow, patient, endless. And for tonight, you are part of it too. If you were to draw a volcano from memory, you'd probably sketch a tall mountain, narrow at the top, wide at the base, with a little wisp of smoke drifting from its peak. It's the classic image, almost childlike in its simplicity. And yet, like most things in nature, volcanoes refuse to fit neatly into a single shape. They come in families, related, but each with its own personality. Let's start with the most famous of them all, the stratovolcano. Even the name sounds dignified, like a professor in a well-pressed suit. Stratovolcanoes are tall, steep, and layered. Strata means layers in Latin. They're built over time by alternating eruptions of ash and lava, each layer hardening before the next arrives. Think of it as geological lasagna, except much hotter and somewhat less appetizing. Mount Fuji in Japan, Mount Vesuvius in Italy, Mount St. Helens in the United States. These are all stratovolcanoes. They rise dramatically from the landscape, their symmetry so perfect it feels almost deliberate. They look peaceful from a distance, sleeping giants in the mist. But inside, their magma is thick and restless, like molten honey in a sealed jar. And when they wake, they don't whisper. Stratovolcano eruptions are among the most explosive on Earth. The pressure builds slowly, decades, centuries, until it becomes unbearable. Then, with a single release, the mountain tears itself apart. It's not anger. It's physics. Hot gases expand, the rock above gives way, and the world holds its breath. Mount St. Helens, for instance, erupted in 1980. Before that, it was considered tranquil, even picturesque, the kind of mountain that postcards were made of. Then one morning, it simply rearranged the landscape. The top of the mountain blew away, forests flattened, ash covered cities hundreds of miles away. And yet, from that chaos, new life began almost immediately. Within months, wildflowers sprouted in the ash. Within years, animals returned. The earth, it seems, doesn't dwell on tragedy for long. Now, if stratovolcanoes are the dramatic artists of the volcanic world, then shield volcanoes are the patient architects. They're broad, wide, and gently sloped, like shields lying on the ground, hence the name. These volcanoes form from lava that flows easily, spreading thin and far before cooling. Instead of violent explosions, they build themselves gradually, layer after layer of lava pouring quietly across the land. The Hawaiian volcanoes are the perfect example. Mauna Loa, whose name means long mountain, is so vast that it covers half the big island of Hawaii. If you measure it from its base on the ocean floor, it's actually taller than Mount Everest. It doesn't look that way, though. Its slopes are so gentle that you could drive a car up them without noticing you're climbing a mountain. Well, at least until your tires start to melt. Then you'll notice. Shield volcanoes are calmer, but no less impressive. Their eruptions are less about destruction and more about expansion. They quietly reshape the land, forming new coasts, new cliffs, new worlds. If stratovolcanoes are fireworks, shield volcanoes are candlelight. Steady, persistent, quietly unstoppable. Hawaiian legends speak of Pele, the goddess of volcanoes, who dances across the islands with fire in her hair and ash at her feet. You don't need to believe in her to understand the poetry behind it. The lava that flows from Mauna Loa, or Kilauea, is creation in motion. It's the planet writing itself anew, glowing liquid paragraphs of geology. Then there are calderas, the great sunken scars left behind when a volcano collapses into itself. The word comes from the Spanish for cauldron, which feels fitting. They're vast, circular basins, sometimes miles wide. Formed after a major eruption empties a magma chamber below. Without support from beneath, the ground gives way, and the once proud mountain becomes a hollow memory. But calderas, too, are not the end of the story. Many of them fill with water over time, becoming lakes of serene beauty that hide their violent origins. Crater Lake in Oregon, for example, is a perfect circle of deep blue, so calm you could mistake it for tranquility itself. And yet, it's the quiet resting place of one of the most catastrophic eruptions in North American history. It's a good reminder that stillness doesn't always mean peace. Sometimes it means recovery. Some calderas, like Yellowstone in the United States, are supervolcanoes, a rather dramatic term, but not undeserved. These are vast volcanic systems with magma chambers so large they can't even be fully mapped. If they erupt, and to be clear, that's a very big if, the result would be global in scale. Yellowstone last erupted about 640,000 years ago. Since then, it has mostly contented itself with geysers and hot springs, gentle reminders that the heat beneath has not gone out. Scientists monitor it carefully, not because they expect it to explode tomorrow, but because it offers a rare window into the heart of our planet. It's like studying a sleeping dragon with a stethoscope. You learn a lot, but you try not to wake it. And then, beneath the sea, hidden from view, are the submarine volcanoes. They outnumber those on land by a wide margin. Tens of thousands of them scattered like constellations across the ocean floor. Most will never be seen directly, but their work shapes the planet as much as any mountain. When they erupt, the water above absorbs their fire. Steam, minerals, and heat mix to create hydrothermal vents, towers of mineral deposits that look almost alive, spewing plumes of black smoke into the cold abyss. Around these vents, entire ecosystems thrive. Strange creatures that live without sunlight, feeding on chemical energy from the earth itself. It's one of the great surprises of modern science. Life can exist in darkness, born not from sunlight, but from stone and heat. In a sense, those submarine volcanoes may hold the oldest secret of all, the origin of life itself. Some scientists believe that the first cells formed near such vents, protected by mineral walls, nourished by chemical reactions. So you could say that every volcano, even the quiet ones in the deep, is part of our family tree. And finally, there are the complex volcanoes, hybrids that defy neat categories, combining calderas, domes, and vents like a patchwork of geological temperaments. They are unpredictable, moody even, but somehow that makes them easier to relate to. Nature, after all, doesn't believe in strict definitions. It prefers variations, exceptions, improvisations. The Earth is less like a machine and more like a jazz musician, improvising endlessly, sometimes off-key, but always finding its rhythm again. Across all these types, one thing remains constant. Volcanoes are the architects of Earth's surface. Every continent, every island, every mountain range, they all owe something to fire. Even the air we breathe has volcanic origins. Early eruptions released the gases that formed our atmosphere: carbon dioxide, water vapor, nitrogen. Without volcanoes, there would be no oceans, no rain, and perhaps no life. So the next time you see footage of an eruption, remember that you are watching the planet make itself possible. It's not chaos, it's choreography. And though we study them now with satellites and sensors, there's still something humbling about standing near one. The smell of sulfur, the faint tremor underfoot, the slow exhale of steam rising from the crater. It's like hearing the planet sigh in its sleep. You might even smile a little, realizing that the Earth, too, occasionally has bad dreams. If volcanoes are the breath of the planet, then eruptions are its size, some soft, some thunderous, all necessary. They are the punctuation marks of geological time, the moments when the Earth lifts its pen and presses a little too hard. When we think of volcanic eruptions, we imagine chaos, fire, smoke, explosions. But from the planet's perspective, it's simply an adjustment, a release of pressure, a balancing act. It's less of a disaster and more of a deep exhale after holding your breath for too long. Still, for those of us standing on the surface, it's quite a show. Let's begin with the most graceful of eruptions, the lava flow. It's hard not to feel awe watching lava move. At first glance, it seems slow, deliberate, even lazy. But don't be fooled by its pace. That glowing red river can melt stone, swallow forests, and quietly reshape everything it touches. Lava is patient. It doesn't need to hurry. It knows that given time, it will reach everywhere it intends to go. When it first pours out of a vent, its temperature can exceed 1,000 degrees Celsius, hot enough to turn sand into glass. Yet when you see it from a distance, it looks peaceful, like candle wax sliding down a table or honey poured in slow motion. That's the trick of lava. It's both terrifying and hypnotic. There are two main kinds of lava, and their names come from the Hawaiian language because, frankly, Hawaiian people have been dealing with lava far longer than most of us. The first is pahuho, smooth, ropey lava that cools into intricate folds and textures. It moves like silk in slow motion. You could almost call it elegant if you weren't aware that it's hotter than your oven by several orders of magnitude. The second is rough, jagged lava that breaks into sharp chunks as it cools. The name itself sounds like what you'd say if you stepped on it barefoot. Both types tell us something about the speed and temperature of the eruption. Pahuho means the lava moved slowly, giving it time to smooth out. Means it cooled faster, cracking as it went. It's the planet's way of telling you how it was feeling that day. Of course, not all eruptions are so polite. Some volcanoes prefer drama. When magma is thick and full of gas, it resists being pushed out until the pressure becomes unbearable. Then, suddenly, it bursts, releasing clouds of ash, gas, and shattered rock at terrifying speed. This is what we call a pyroclastic flow. The word comes from the Greek, pyro for fire, klastos for broken. And that's exactly what it is. A rushing avalanche of fire and fragments. A cloud so hot and fast, it can outrun anything on Earth. These flows can reach temperatures of over 700 degrees Celsius and move faster than a car on the highway. They don't burn things. They simply erase them. In the year 79 CE, Mount Vesuvius unleashed one of the most famous pyroclastic flows in history. It buried the Roman cities of Pompeii and Herculaneum under meters of ash. The people there never had time to run. They were frozen in their final moments, a grim but strangely poignant record of human life paused mid-sentence. And yet, that tragedy also preserved their world. 2,000 years later, archaeologists found bread still sitting in ovens, rings on fingers, frescoes on walls, the details of daily life perfectly captured in volcanic plaster. Vesuvius destroyed, but in doing so, it also remembered. That's the dual nature of volcanoes again. Destroyers, but also storytellers. When the 1883 eruption of Krakatoa occurred in Indonesia, The explosion was so powerful that it was heard 3,000 miles away. To put that in perspective, if you had been sitting quietly in India, you might have wondered why the world suddenly sounded like it was tearing in half. The blast generated waves that circled the globe multiple times. Ash darkened skies for days. Sunsets turned blood red around the world. Even in London, thousands of miles away, people described seeing blue suns through the haze. The earth had spoken loudly enough for everyone to hear. And when the sound faded, the temperature of the planet dropped. The fine ash in the atmosphere reflected sunlight back into space, cooling the earth by more than a degree for several years. That's another thing about volcanoes. Their power doesn't end at the horizon. They can change the color of the sky. They can alter the climate. They can make sunsets beautiful and winters longer. A century later, in 1991, Mount Pinatubo in the Philippines erupted. It was one of the largest eruptions of the 20th century. The explosion sent a column of ash more than 35 kilometers into the sky. So high, it reached the stratosphere. The ash spread around the planet, creating a thin veil that cooled global temperatures by about 0.5 degrees Celsius. It doesn't sound like much, but for climate scientists, that's extraordinary. The Earth's thermostat had been nudged by one mountain. It's humbling, isn't it? We talk so much about human influence on the planet, and rightly so. But nature occasionally reminds us that it too has its hand on the switch. And then there's the ash itself, the confetti of destruction. Fine, gray, and deceptively light. It can travel vast distances through the air, carried by winds until it falls softly on places that never saw the eruption. After Iceland's Eyjafjallajökull erupted in 2010. And yes, that's a name best attempted only after 2 cups of coffee. Ash drifted across Europe, grounding thousands of flights. For days, airports were silent, skies empty. It was as if the planet had politely asked humanity to pause and look up. If lava flows are slow painters, then ash clouds are impressionists. Blurring the horizon, softening light, reminding us how fragile visibility can be. Volcanic ash may seem like a nuisance, but it's full of minerals that, once settled, enrich the soil. Give it time, a few years, a few decades, and what was once gray and lifeless becomes green again. The earth always keeps its receipts. One might ask, why do we live near volcanoes at all? It seems like poor judgment, doesn't it? But the answer is simple. Life follows fertility. Volcanic soil produces some of the richest crops on Earth. From the coffee plantations of Central America to the vineyards on the slopes of Mount Etna in Sicily, people have always been drawn to volcanic land. It's a little like living next to a temperamental artist. You get the beauty, but you accept the occasional outburst. Volcanoes also shape the weather in subtler ways. Even small eruptions release steam and carbon dioxide, both of which play roles in atmospheric chemistry. Over geological time, volcanoes have helped stabilize Earth's temperature by balancing carbon dioxide levels. Too little, and the planet would freeze. Too much, and it would burn. It's a delicate dance. And somehow, despite the occasional fiery tantrum, the Earth keeps time perfectly. But perhaps the most fascinating thing about eruptions is not their violence, but their artistry. Each eruption leaves a fingerprint. Layers of ash, unique chemical signatures in rock, traces of minerals that reveal how hot and deep the magma once was. Geologists can read these like tree rings, decoding stories written millions of years ago. Somewhere in Iceland, a young scientist crouches beside a cooling lava field, measuring gas, collecting samples, smiling quietly to themselves as they realize they are literally touching time. When volcanoes sleep, they seem eternal. When they wake, they remind us that nothing truly is. And between those two states, between silence and fire, is the whole story of our planet. It's tempting to think of volcanoes as destructive, as the villains of geology. After all, they burn, bury, and break the land. But spend a little time studying them, and you realize something quietly astonishing. Volcanoes are the planet's way of creating beauty through renewal. They destroy in order to rebuild. It's a harsh method, yes, but one that has worked for 4.5 billion years. When a volcano erupts, it tears open the crust, spilling the contents of the deep earth onto its surface. What comes up is more than molten rock. It's chemistry, history, and memory all at once. Every eruption refreshes the planet's surface, creating new layers of minerals, new mountains, new landforms. If you could speed up time, say, compress 1,000,000 years into a single minute, you'd see continents shifting like slow dancers, mountains rising, islands appearing from the sea. It would look almost alive. And in a sense it is. The Earth is a living planet, not in the biological sense, but in the way it moves, changes, and heals. Volcanoes are its pulse. Some of the most beautiful places on Earth exist because of volcanic activity. Think of Iceland, a land that quite literally grows each year as lava solidifies at its coasts. Or Japan, where mountain ranges rise sharply from the sea, born of countless ancient eruptions. Even New Zealand's lush landscapes, steaming valleys and turquoise crater lakes, are the result of a restless planet finding its rhythm. It's funny to think that the same forces that terrify us are also responsible for some of the most breathtaking scenery on Earth. But that's geology for you. It has a flair for drama. When lava cools and hardens, it weathers slowly under wind and rain. Over centuries, it breaks down into tiny particles: iron, magnesium, calcium, potassium, the essential ingredients of fertile soil. Plants love it. So do people. That's why civilizations have always been drawn to volcanic regions. The slopes of Mount Vesuvius in Italy are dotted with vineyards. The rice terraces of Java climb the ridges of sleeping volcanoes. The coffee of Central America, rich and dark, owes its flavor to the ashes of ancient fire. It's one of nature's most poetic exchanges. Life blooming from destruction. Of course, not all volcanic gifts are so romantic. Sometimes they come disguised as inconvenience. For example, volcanic gases, carbon dioxide, sulfur dioxide, and water vapor can fill the sky after an eruption, blocking sunlight and cooling the planet. We saw it after Mount Pinatubo in 1991, and after the great Icelandic eruption of Laki in 1783, which dimmed skies across Europe and caused one of the coldest summers on record. Yet even those disruptions have a purpose. Volcanoes are nature's climate regulators. They may cool or warm the Earth in the short term, but over geological timescales, they help maintain balance. Without volcanoes, we might not have an atmosphere at all. When the Earth was young, its surface was a molten chaos. No oceans, no air, no life. It was volcanoes that exhaled the gases that formed our first atmosphere: carbon dioxide, nitrogen, and steam. As that steam condensed, the first rains fell and the first oceans gathered. It's humbling, really. The same forces that once made the world uninhabitable later made it livable. And they continue to do so today, quietly, beneath our feet. Volcanoes don't just shape the surface. They shape the energy of the planet. Beneath volcanic regions, the crust remains hot. That heat can be tapped, a gift of clean, renewable energy called geothermal power. In Iceland, almost every home is heated by this hidden warmth. Pipes run deep into the earth, drawing up hot water and steam, which power turbines and warm houses, all without a single puff of smoke from a chimney. It's an elegant symmetry. The same planet that burns can also comfort. When you take a hot shower in Reykjavik, you're quite literally bathing in volcanic breath. And then there's the quiet artistry of volcanic landscapes themselves. When lava cools rapidly, it sometimes forms strange geometric shapes, columns of hexagonal rock that look almost too perfect to be natural. You can see them in places like the Giant's Causeway in Northern Ireland and Devil's Post Pile in California. Each column fits neatly beside its neighbor, like a tessellation drawn by a patient mathematician. And in a way, that's exactly what it is. Nature is a mathematician. It writes its proofs in stone. Some volcanoes leave behind obsidian, a dark, glassy rock formed when lava cools so quickly that crystals have no time to form. For ancient peoples, obsidian was a marvel. Sharp, beautiful, mysterious. They used it to make blades sharper than steel and mirrors so smooth they were said to show the spirit as well as the face. It's fascinating how something born of fire and chaos can become a tool for clarity. Maybe that's a lesson in itself. And sometimes, volcanoes give us entire worlds. The Hawaiian Islands, for example, exist solely because of volcanic activity. Every ridge, every beach, every palm tree rests on layers of hardened lava that once flowed red and molten from the sea. Even as you read this, new land is forming somewhere on the ocean floor. A newborn island, invisible for now, slowly building itself upward, patiently awaiting its first sunrise. Volcanoes are builders. They may work in fire, but their purpose is creation. But there's another side to their influence, one that's quieter, subtler, and endlessly fascinating. Volcanoes change not only the land, but the air. Every major eruption releases vast amounts of water vapor, carbon dioxide, and sulfur compounds. Those sulfur particles reflect sunlight, sometimes enough to cool the entire planet by a degree or two. After the eruption of Tambora in 1815, the Earth experienced what became known as the year without a summer. Crops failed, snow fell in June, and sunsets turned crimson across the northern hemisphere. It was a time of hardship, but also of art. Painters captured those strange, blood-red skies. Poets wrote of strange light and endless twilight. Even Mary Shelley, trapped indoors by the gloomy weather near Lake Geneva, used that eerie atmosphere as inspiration for Frankenstein. So, in a way, a volcano helped create one of literature's greatest stories. It's strange, isn't it? How destruction, when viewed through time, becomes inspiration. The Earth writes tragedies that later become masterpieces. Maybe we all do, in our own way. Volcanoes also shape the oceans. When underwater eruptions occur, minerals pour into the sea, nourishing plankton and other microscopic life. Those tiny organisms, in turn, form the foundation of marine ecosystems. So even the fish we eat, the corals that color the reefs, and the oxygen we breathe, owe something to volcanoes. The ocean's life depends, quite literally, on the Earth's fire. It's a nice reminder that opposites are not enemies. They're collaborators. Scientists have even found that volcanic eruptions over millions of years helped stabilize the Earth's temperature. When carbon dioxide levels rose, increased volcanic weathering drew it back out of the atmosphere. The process is slow, glacial even, but it's the reason our planet has remained habitable for billions of years. The Earth, it seems, knows how to take care of itself. It's also worth noting that volcanoes, for all their ferocity, are astonishingly fragile. Their shapes can erode quickly by wind, rain, ice, or even human hands. What seems eternal from afar can vanish in a few thousand years, which, to geology, is the blink of an eye. Perhaps that's why we find them so moving. They remind us that permanence is an illusion, and that even mountains are temporary thoughts in the mind of the Earth. And yet, as they fade, they give back. Ash becomes soil. Magma becomes minerals. Even the gases they release find their way into the cycles that sustain life. In their own fiery way, volcanoes are caretakers. They destroy, yes, but only to make room for what comes next. Maybe that's why people living near volcanoes often speak of them with affection rather than fear. They know the risks, but they also know the rewards. When you live near a volcano, you learn to listen to the tremors, the warmth, the whispers in the air. You learn patience, you learn respect, and perhaps you learn a bit about resilience, the art of beginning again. The deeper you study volcanoes, the stranger they become. They're not just fire and rock. They're chemistry, color, and sometimes unintentional comedy. They prove that the Earth has a sense of humor, though it expresses it through rather dramatic means. We often imagine volcanoes as red, glowing, molten, like the heart of a forge. But not all lava burns the same hue. Some volcanoes burn blue. On the island of Java in Indonesia, there's a volcano called Kawah Ijen. At night, it glows with an eerie sapphire light. Tourists hike up its slopes in the dark just to see it. Blue flames curling out of the earth like something out of a dream. But the lava isn't really blue. It's an illusion, a trick of chemistry. You see, the volcano emits large amounts of sulfur gas. When the gas meets oxygen and ignites, it burns with a vivid electric blue flame. So what you're seeing isn't molten rock glowing blue. It's sulfur catching fire in the night air. Still, it's mesmerizing. The flames flicker and dance like ghostly rivers of cobalt. They remind us that science doesn't make the world less magical. It just explains how the magic works. Sulfur itself is one of the many strange children of volcanic chemistry. It's the element that gives volcanoes their distinctive smell. That faint, rotten egg odor that clings to the air long after an eruption. It's also essential for life. Without sulfur, your body couldn't make certain amino acids, and without those, you wouldn't exist. So the next time someone complains about the smell near a hot spring, you can politely remind them that they're, quite literally, smelling the building blocks of life. Speaking of hot springs, let's talk about them. They're the gentlest expression of volcanic energy, like sighs of heat escaping from the Earth's surface. Beneath the crust, groundwater seeps into cracks and fractures, warming as it descends toward hot rock. Eventually, the water becomes so hot, it rises back up, emerging as a steaming pool or a bubbling spring. Some are calm and serene, natural baths surrounded by mist. Others are unpredictable, erupting in rhythmic bursts of steam and water. Those are geysers. The word geyser comes from the Icelandic geisa, meaning to gush. It's a wonderfully direct term. If you've ever watched one, you know exactly why. Perhaps the most famous geyser is Old Faithful in Yellowstone National Park. Every 90 minutes or so, it shoots a column of boiling water nearly 40 meters into the air. It's been doing this with remarkable consistency for centuries. In a world where most things are unpredictable, Old Faithful is the Earth's most punctual performer. But there's a kind of tenderness in its regularity. It reminds us that even chaos can have rhythm. Yellowstone itself, of course, sits atop a vast volcanic system, a sleeping supervolcano, as we mentioned before. The entire park is a kind of breathing landscape, alive with heat beneath its surface. Hot springs shimmer with impossible colors, turquoise, emerald, gold, created by microorganisms that thrive in the boiling water. Each color corresponds to a particular species, each adapted to a different temperature range. It's as if life has painted itself onto the Earth's skin. You could stand there for hours, watching the steam drift and the colors shift with the light. It feels almost unreal, a watercolor painted by geology and time. Not all volcanic expressions are so gentle, of course. Sometimes the Earth burps mud. These are mud volcanoes. They don't erupt lava, but a slurry of mud, water, and gases, mainly methane. They form when gas rises through soft sediment, mixing it into a bubbling mess that oozes rather than explodes. They look a bit like mini volcanoes, complete with craters and small cones. But their eruptions are, let's say, less cinematic. You'll find them in places like Azerbaijan, where hundreds of these bubbling mounds cover the landscape. When they erupt, they often make a delightful glorp sound, as if the planet were trying to clear its throat. It's geology's comic relief. Then there are the acid lakes, pools so acidic that they could dissolve metal, yet somehow gleam in perfect, unearthly blues and greens. These form in volcanic craters where gases bubble through water, creating sulfuric acid. One of the most famous is, again, in Kawa-Ijen. Its turquoise lake is stunning from a distance, but deadly up close. The air above it is thick with sulfur fumes. The water is hot enough to scald and so acidic it could burn through fabric. And yet, when the sun rises, the light refracts through the mist, and the lake glows like liquid jade. Nature, it seems, has an exquisite sense of irony. Another wonder of volcanic landscapes are the fumaroles, small vents that release steam and gas from the Earth's crust. They hiss and whisper, sometimes softly, sometimes with a shriek. If you walk through a volcanic valley like Dalal in Ethiopia, you'll hear them sing, a chorus of gas escaping from underground, an orchestra conducted by pressure. The air smells sharp, metallic. The ground is streaked with colors, yellow from sulfur, red from iron, green from copper. It's like standing inside a painter's palette left too close to the fire. Some fumaroles even ignite naturally, creating eternal flames. These are places where gas seeps through rock and catches fire, burning endlessly as long as the supply lasts. There's one in Turkey that's been alight for over 2,100 years. A flickering candle on the mountainside that never goes out. It's been worshipped, studied, and occasionally used to light tourist cigarettes, though that last one isn't exactly encouraged. Still, there's something poetic about it. the Earth's own eternal lantern. And then, in some volcanic valleys, you'll find boiling mud pools, thick gray cauldrons that bubble and spit like soup on a hot stove. Each bubble bursts with a soft blop, sending tiny droplets into the air. Stand near one, and it feels like the planet is chuckling quietly to itself, as if to say, "Don't take me too seriously." It's a strange comfort to know that even the Earth, for all its grandeur, still makes funny noises sometimes. There are also volcanic lightning storms, those surreal moments when ash clouds generate their own weather. As volcanic particles collide, they build up static electricity. And then, within the dark column of smoke, lightning flashes. Bright veins of electricity in a sky already glowing with fire. It's one of the most breathtaking sights on Earth. A storm born from stone. A paradox of destruction that looks like divine choreography. Scientists study it carefully, but even they admit it's hard not to feel a little awe. And awe, after all, is the first step toward understanding. Even stranger are cryovolcanoes. Volcanoes that erupt not lava, but ice. They exist on distant worlds, on moons like Enceladus and Europa, and on the dwarf planet Pluto. There, the temperatures are so low that water, ammonia, or methane behave like molten rock. When they erupt, they spray frozen plumes into space, forming new crusts of ice instead of stone. So, in a way, even the coldest places in the solar system still have volcanoes. They just trade fire for frost. Isn't that beautiful? No matter how far we travel, we keep finding the same patterns: eruption, renewal, stillness. The universe repeats itself, like a lullaby sung in different keys. Back here on Earth, volcanoes also give rise to strange lakes of liquid rock, lava lakes, glowing and roiling, their surfaces shifting like living skin. There are only a few permanent lava lakes in the world. In places like Mount Erebus in Antarctica and Mount Nyiragongo in the Congo. Standing near one is like peering into the Earth's heartbeat. You can see the lava rise and fall, pulsing gently as if inhaling and exhaling. Scientists have described it as hypnotic. Artists have described it as holy. Both are right. And then there are the volcanic ice caves, where fire and frost meet in the same breath. In Iceland, lava once flowed beneath glaciers, melting tunnels through the ice. When the lava cooled and the ice refroze, it left behind glowing caverns of blue crystal, lit by shafts of pale light. It's one of those places that seems impossible, where opposites coexist quietly, like a dream the Earth forgot to end. All these strange features, blue flames, boiling mud, lightning clouds, frozen volcanoes, they remind us of a simple truth. The planet is not just alive, it's imaginative. It experiments. It paints with elements, plays with temperature, and occasionally cracks a joke in the form of a mud bubble. And somehow, it all works. Every sound, every shimmer, every plume, they're all part of the same conversation between rock, air, and time. It's a humbling thing, really, to study something that can erase your laboratory in an instant. Volcanologists, those brave, slightly eccentric scientists who dedicate their lives to volcanoes, live in constant conversation with danger. They measure mountains that could, at any moment, decide to move. And yet, there's no panic in their work. Quite the opposite. They are among the calmest people you'll ever meet. To study volcanoes properly, you must first learn patience. You can't rush the Earth. A volcano does not send calendar invites. It does not warn you in bold red letters that it plans to erupt next Thursday at 4 p.m. Instead, it murmurs. It hints. It changes its breath ever so slightly and waits to see if you're paying attention. That's where science comes in. Modern volcanology is, in essence, the art of listening. We listen not with ears, but with instruments, seismometers, gas sensors, satellites, and drones, each one tuned to detect the subtle language of the Earth. A seismometer measures vibrations. It's the same device that detects earthquakes, but volcanologists use it to hear the tiny tremors that ripple through the ground as magma moves below. When magma rises, it pushes rock aside. That friction creates small earthquakes, so small that you or I wouldn't feel them, but sensitive equipment picks them up. When the pattern of those quakes changes, it's a sign that something deep below is stirring. You could say that volcanologists are, in a sense, geologic cardiologists. They read the heartbeat of the mountain. Then there's gas monitoring. As magma nears the surface, it releases gases: carbon dioxide, sulfur dioxide, hydrogen sulfide. By measuring these emissions, scientists can estimate how close the magma is to erupting. It's like catching the faint scent of smoke before the fire becomes visible. Some volcanoes release these gases through cracks called fumaroles. Researchers often place sensors directly over them, sometimes using long poles, sometimes with drones. And occasionally, I imagine, while questioning their career choices. The key is balance. Get close enough to learn, but not close enough to become part of the experiment. Satellites, too, have become essential tools. Orbiting hundreds of kilometers above the Earth, they can detect even the slightest changes in a volcano's shape. If the ground bulges outward, it means magma is accumulating below, a bit like bread dough rising under a cloth. The technology is astonishing. We can now measure vertical movement in millimeters from space. It's the ultimate long-distance relationship. Scientists and volcanoes communicating through pixels and radio waves. Thermal cameras capture heat signatures, revealing places where the crust has warmed. Drones, nimble and fearless, fly through ash plumes to collect samples and videos. And artificial intelligence, still young but promising, analyzes patterns in volcanic data, helping predict when an eruption might occur. We can't yet predict them perfectly. Volcanoes still keep their secrets. But our understanding improves with every decade. And even when predictions fail, the data tells stories. Each tremor, each puff of steam, is another line in the Earth's autobiography. You might wonder how volcanologists manage their nerves. After all, their work involves climbing unstable slopes, breathing sulfur fumes, and occasionally fleeing from things that move faster than cars. But ask one of them, and they'll likely smile and say something like, "Oh, you get used to it." That's science in a nutshell. The calm acceptance that curiosity is worth the risk. Some carry gas masks and thermal suits. Others carry notebooks and thermocouples, tiny devices for measuring heat. And almost all of them carry a quiet sense of awe. Because standing on the rim of an active volcano is like shaking hands with the Earth itself. Imagine it. The ground humming beneath your boots, the air thick with heat and sulfur, the sound of rocks cracking somewhere deep below. Every sense sharpened, every thought stripped of triviality. It's impossible not to feel small, and yet, somehow, deeply connected. That's the paradox of science at its best. The more you learn, the smaller you feel. and the more wondrous the world becomes. Volcano monitoring is not just about prediction. It's about protection. In places like Japan, Italy, and Indonesia, countries where people live close to active volcanoes, early warning systems save lives. Networks of sensors send data to control centers where computers analyze tremors and gas levels in real time. When something changes, alerts go out to nearby towns. Sometimes, people have hours to evacuate. Sometimes, only minutes. It's never perfect. Nature rarely gives perfect warnings. But each successful evacuation is a quiet triumph of knowledge over chaos. One of the most powerful examples comes from Mount Pinatubo, the same volcano that erupted in 1991. Thanks to monitoring by scientists from the Philippines and the United States, tens of thousands of people were evacuated in time. The eruption was massive, but far fewer lives were lost than there might have been. It's easy to forget how extraordinary that is. For most of human history, volcanoes erupted without warning, and people simply endured. Now, for the first time, we can listen to the planet's whispers and act before it shouts. That's progress. The quiet, unspectacular kind that rarely makes headlines, but saves lives all the same. Of course, technology doesn't replace humility. Volcanoes have a way of surprising even their most devoted students. They do things that make no sense, eruption patterns that defy models, gases that appear without warning, plumes that rise higher than physics predicted. It keeps scientists humble. And humility, in science, isn't weakness, it's wisdom. To study volcanoes properly, you must be willing to say, "I don't know," and mean it with respect. Because the Earth doesn't care about our certainty. It only cares that we keep listening. In the last few decades, we've even begun to study volcanoes on other worlds. Mars, for example, has the largest volcano in the solar system, Olympus Mons. It's nearly 3 times as tall as Mount Everest, and so wide that you could fit the entire state of Arizona on its base. It hasn't erupted in millions of years, but it stands as a monument to the past heat of Mars, a frozen echo of what once was. On Jupiter's moon, Io, volcanoes still erupt regularly, fountains of molten sulfur shooting hundreds of kilometers into space. If you could stand there, which, frankly, you shouldn't, you'd see a sky filled with arcs of yellow and red plasma. It's beautiful, and also absolutely lethal. Still, it reminds us that volcanism is universal, a planetary language spoken wherever worlds are young or restless. The cosmos, it seems, loves to erupt. Back on Earth, the field of volcanology has become a blend of science and art. Researchers create 3D models of magma chambers, simulate eruptions with supercomputers, and even recreate mini volcanoes in the lab. They mix molten basalt in crucibles, watching how it cools and crystallizes, like chefs studying recipes written in fire. And they do it with a kind of devotion that borders on poetry. Because, for all the instruments and equations, there's still something profoundly human about standing before a mountain and wanting to understand it. Sometimes, when the data quiets down and the instruments hum softly in the background, I imagine a volcanologist sitting in their camp at dusk, a small tent pitched near the slope of an ancient crater, steam rising in the distance, the air thick with the smell of sulfur and evening rain. They sip lukewarm coffee, scribble notes by flashlight, and smile at the absurdity of it all. Studying volcanoes is, in many ways, an act of faith. Faith in reason, faith in the idea that understanding can coexist with awe. And it does. Every reading, every measurement, every tremor is another thread in the long conversation between humanity and the earth. We don't just study volcanoes to protect ourselves. We study them because they tell us who we are, creatures of curiosity living on a restless, breathing world. We came from stardust, but we live on magma. And somehow, we've learned to make peace with that. History remembers volcanoes the way it remembers gods, with awe, fear, and reluctant admiration. They have shaped civilizations, erased them, and left behind silent lessons written in ash. Every continent has its stories, and every story, somehow, begins the same way. With the ground trembling, the sky darkening, and someone looking up, realizing that the world they thought was solid was breathing all along. Let's start with one of the most famous names in geology, Vesuvius. It sits quietly near Naples, Italy, its slopes green and deceptively calm. But beneath that peaceful surface lies one of the most studied volcanoes on Earth. In the year 79 AD, Vesuvius erupted with unimaginable power. It released a column of ash and gas that shot over 30 kilometers into the sky. The nearby cities of Pompeii and Herculaneum were buried under a thick layer of volcanic ash and pumice. Thousands died. But what makes this eruption unforgettable is how perfectly it preserved life as it was. When archaeologists excavated Pompeii centuries later, they found everything frozen in place. Bread still baking in ovens, tools lying beside half-finished work, and even the outlines of people captured in their final moments. Volcanic ash, when it falls fast and thick, seals the world like a photograph. It blocks air, halts decay, and turns tragedy into time capsules. Pompeii, in a grim twist of fate, became one of the best-preserved cities of the ancient world. It taught us how Romans lived, their architecture, art, and even their graffiti. It showed us that history doesn't only live in scrolls and books, but sometimes in dust. The eruption of Vesuvius wasn't unique. Across history, volcanoes have rewritten maps and mythologies alike. Take the Krakatoa eruption of 1883. Located between the islands of Java and Sumatra in Indonesia, it produced one of the loudest sounds ever recorded on Earth. The explosion was heard nearly 5,000 kilometers away. That's roughly the distance from New York to London. The blast sent tsunamis racing across the ocean and threw ash so high into the atmosphere that sunsets around the world glowed crimson for years. Painters in Europe unknowingly captured its aftermath. Turner-like skies of blood and gold. Global temperatures dropped. The moon looked strange for months. And people began to realize that what happens on one island can change the world's climate. In that sense, Krakatoa was a lesson in connectedness, a reminder that the Earth doesn't recognize borders. Then there was Mount Tambora, another Indonesian giant that erupted in 1815. The largest volcanic eruption in recorded history. It released more ash than any modern volcano, enough to blot out sunlight across entire continents. The following year became known as the year without a summer. Snow fell in June in North America. Frost killed crops in Europe. The sky turned strange, the sunsets more vivid than ever. Beauty born from destruction. And in that odd, cold summer, a group of writers gathered in a villa by Lake Geneva. Among them was Mary Shelley. As the world darkened outside, she wrote a story about lightning, creation, and monsters. Frankenstein was born, in the literal shadow of a volcano. You could say Tambora inspired not just a chill in the air, but a chill in literature itself. Volcanoes have a way of shaping imagination as much as geography. In ancient Japan, Mount Fuji became a sacred symbol, a perfect cone rising above mist, both beautiful and formidable. Poets wrote of it as a doorway between worlds, artists painted it in all seasons, and even today, it feels more like a spirit than a mountain. In Hawaii, volcanoes are not just geological formations. They are divine presences. Pele, the goddess of fire, is said to dwell within Kilauea, her moods reflected in the volcano's behavior. When she sleeps, the land is calm. When she stirs, the earth flows with molten light. It's a poetic metaphor, yes, but also a reflection of deep respect. An acknowledgement that the earth is not ours to command, only to coexist with. Other eruptions changed history in quieter ways. The Laki eruption in Iceland in 1783 released so much sulfur that it poisoned crops and livestock, causing famine across the island. The resulting haze spread over Europe, lowering temperatures and darkening skies. It may even have contributed to unrest that led, years later, to the French Revolution. Who would have thought a volcano in Iceland helping light the fires of revolution in France? History, like geology, is full of unpredictable connections. Even more recently, Mount St. Helens in Washington state erupted in 1980. Scientists had been monitoring it closely, but the scale of the lateral blast, sideways, not upward, caught everyone off guard. The eruption flattened forests, melted glaciers, and sent an ash cloud circling the globe. Yet from that devastation came rebirth. Within months, tiny plants began to sprout through the gray dust. Animals returned, cautiously at first, then in abundance. The land healed itself, as it always does. One of the most haunting modern examples is Mount Pinatubo in 1991. We've already mentioned it in the context of early warnings, but it deserves a quiet moment here too. Its eruption cooled the planet by nearly 0.5 degrees Celsius, a measurable global impact from a single mountain. For a while, the sunsets turned copper and rose. The world glowed, and then, gradually, the skies cleared. The earth exhaled. Volcanoes even shaped human migration. When Mount Toba erupted around 74,000 years ago, a supervolcano in what is now Indonesia, it released enough ash to darken the sky for years. Some scientists believe it triggered a volcanic winter that reduced human populations to just a few thousand survivors. If that's true, then every one of us alive today may descend from those few who endured that darkness. We carry, somewhere deep in our DNA, the memory of fire and survival. It's a humbling thought that the story of humanity might have turned on a single explosion. And yet, for all their terror, volcanoes also gave us what we needed to thrive. The fertile soils of Italy, Indonesia, Japan, and Central America owe their richness to ancient eruptions. Without volcanoes, civilization might have grown slower or differently. They are both destroyers and nurturers. An odd combination, perhaps. But then again, so are we. There's a kind of cosmic irony in how volcanoes mirror life itself. They build, they break, they change form. They rest for centuries, only to awaken when least expected. And through it all, they teach patience. Because nothing on this planet, not even a mountain, is truly still. Ancient peoples understood this intuitively. They built myths not just to explain volcanoes, but to live with them. In Central America, The Maya spoke of mountains that breathed fire as gateways to the underworld. In Greece, the god Hephaestus forged his weapons beneath Mount Etna, his hammer blows echoing through the ground. Even the Bible speaks of pillars of smoke and fire, imagery drawn from humanity's oldest teacher, the earth itself. Science may have replaced mythology in our explanations, but not in our sense of wonder. We may know what magma is, but the sight of it still feels divine. If you visit Pompeii today, you can walk streets lined with ancient stones, touch the grooves where chariot wheels once ran, and look up at Vesuvius looming in the distance, silent, green, serene. It's easy to forget what it's capable of. And yet, the people who live there do not forget. They build, they grow vines. They live in the shadow of something ancient and unpredictable. And somehow, they call it home. That might be the most human thing of all. Volcanoes remind us that permanence is a dream, and that's okay. They give us perspective. They remind us that destruction and creation are not opposites, but partners in the same dance. And perhaps that's why, even after millennia of eruptions and fear, we still find them beautiful. Because in the glow of lava, we see something of ourselves. Fragile, powerful, brief, and endlessly curious. Have you ever noticed how people talk about volcanoes the same way they talk about feelings? We say things like, he's about to erupt, or she's boiling with anger, or there's tension beneath the surface. It's not a coincidence. Volcanoes are the Earth's emotions made visible. They are pressure, release, transformation, the same things that happen inside us, just on a scale too grand for words. When magma rises beneath a volcano, it moves slowly, patiently. It doesn't explode right away. It gathers strength, melts rock, builds pressure, until something shifts. And then, suddenly, it all changes. Human beings aren't so different. We hold things in. We simmer quietly beneath calm exteriors. Then one day, a word, a memory, a single spark of stress, and we erupt, not with lava, but with emotion. It's not destructive by nature. Sometimes it's cleansing. The earth exhales through volcanoes. Maybe we do too. A volcano is, in many ways, a paradox of calm and chaos. Beneath the still surface of a mountain lies a molten world in constant motion. Just as beneath your still face, neurons fire, thoughts churn, blood rushes, ideas collide. And yet, from the outside, you seem tranquil. The earth is a good actor that way. It hides its storms in silence. But silence doesn't mean nothing is happening. In geology, silence is potential. In life, too. Perhaps that's why volcanoes feel so deeply symbolic. They embody both creation and destruction, the two most fundamental forces in the universe. Lava wipes the land clean, but when it cools, it becomes the richest soil imaginable. Fertility born from fire, renewal from ruin. It's tempting to think of that as poetic exaggeration, but it's literal truth. Some of the most productive farmland on Earth lies in the shadows of volcanoes. The same mountain that once destroyed villages now feeds generations. Nature, it seems, knows how to recycle drama into grace. There's something humbling in that, the way the planet forgives itself. We humans tend to dwell on our eruptions, our mistakes, our collapses. But the Earth doesn't apologize when it erupts. It doesn't carry shame. It transforms. It reminds us that endings and beginnings are sometimes the same thing viewed from different altitudes. If you could listen closely enough, you might even say volcanoes have personalities. Some are shy, quiet for centuries. only muttering softly through fumaroles. Others are dramatic, loud, unpredictable, always the center of attention. Mount Etna in Sicily, for example, erupts so often that locals simply shrug and say, "Oh, she's talking again." It's as if the volcano is an old relative, temperamental, yes, but beloved nonetheless. There's affection in that acceptance, a kind of peace in living with unpredictability. Volcanoes also teach us about balance, how too much pressure leads to eruption. In physics, in geology, in emotion, it's always the same story. Pressure builds when energy has nowhere to go. Release, though disruptive, is necessary. Without it, systems collapse. That's true for mountains. It's true for minds. So perhaps when the earth erupts, it's not being cruel. It's simply being honest. And maybe, when we lose our calm, we're doing the same. It's curious. The human fascination with danger we can't control. People travel thousands of miles to stand near active volcanoes. They take photographs, collect pebbles, and post videos titled "Lava Flow at Sunrise." There's something comforting in standing close to destruction and surviving it. As if witnessing chaos safely restores our sense of order. You feel the heat, the trembling ground, and realize you are alive and small and part of something vast. It's terrifying and deeply peaceful at once. That duality, fear and wonder, has followed volcanoes through every culture. In mythology, they're often both gods and monsters, creators and destroyers. They remind us that the universe doesn't pick sides, it just moves. Even now, scientists talk about eruptive cycles, about volcanic lifespans. They describe mountains the way poets describe people, with affection and respect, and a touch of awe. It's science, yes, but it's also storytelling. If you think about it, volcanoes are the reason we have continents, atmospheres, oceans, even life itself. The gases released from early volcanic activity formed much of the air we breathe. The crust we stand on is built from cooled lava flows. Without volcanoes, the Earth would be cold, inert, and silent. They are, quite literally, the breath of the planet. So when you see smoke rising from a mountain, you're not watching destruction. You're watching the planet exhale. It's strange how easily we forget that the solid ground beneath us is only an illusion of stability. We build cities, draw borders, argue over property lines. And beneath it all, magma keeps moving, patient and ancient, reminding us that ownership is temporary. If the Earth ever decides to rearrange itself, it doesn't ask permission. And maybe that's why volcanoes inspire both fear and humility. They remind us we're guests here, clever, noisy guests, but guests all the same. Volcanoes even appear in our dreams, our metaphors, our art. Painters capture their glow. Poets compare them to love and fury. Filmmakers turn them into backdrops for heroism. But perhaps the real heroism is in simply understanding them, in facing something so immense and choosing curiosity over fear. Science, after all, is not the absence of awe. It's awe made articulate. Sometimes, when I'm teaching late at night, and the lights in the lab flicker soft and yellow, I think of volcanoes as metaphors for thought itself. Ideas start deep, unseen, under layers of routine and reason. They rise slowly, pressing upward through layers of doubt, and then, suddenly, they burst forth, molten, imperfect, bright. That's creativity. Messy, unpredictable, but transformative. So maybe volcanoes aren't just geological wonders. Maybe they're the universe's way of showing us how to think, In the end, volcanoes remind us that silence is never empty, that stillness is not stagnation, that what sleeps beneath the surface can awaken in beauty or in fury, and that both are natural. It's an odd comfort, isn't it? To know that the same earth that cradles us also reshapes itself without hesitation. The planet doesn't fear change. It is change. And perhaps, in watching it, we learn how to change too. Now, as the night deepens, let the image soften in your mind. A quiet volcano beneath the stars, its slopes cooling, its lava heart slowing to a gentle glow. The air hums faintly. The stones radiate warmth. Somewhere deep below, magma still moves. Slow, patient, certain. The mountain is resting, but it is never truly asleep. Just like the earth. Just like you. It's quiet now. The great engines of the planet turn unseen beneath the crust, and above them, the world sleeps. For all their fire and fury, volcanoes spend most of their lives in silence. They wait. Sometimes for decades, sometimes for thousands of years. There's something deeply human about that waiting. The patience, the stillness before transformation. The earth is old, yes, but never finished. It's still writing, still revising, still shaping its next chapter beneath our feet. And we are part of that story. Every grain of sand, every stone beneath your home was once liquid fire. Every mountain was once a sea. Every breath you take contains the ghosts of volcanoes long gone. The carbon in your blood, the iron in your heart, the calcium in your bones, all forged in the furnaces of the earth. When you look at a volcano, you are looking at your own ancestry, written not in genes, but in geology. I often wonder, late at night, if the planet dreams. If, somewhere in its molten core, it remembers the first eruption, the first whisper of atmosphere, the first spark of life rising from heat. We like to think of Earth as solid, as stable ground beneath us. But really, it's an organism of sorts, a slow, breathing creature, shifting and murmuring in its sleep. And perhaps that's why volcanoes move us so deeply. They remind us that we live on something alive. The word volcano itself comes from Vulcan, the Roman god of fire and metalwork. The divine blacksmith who forged thunderbolts for Jupiter. It's fitting, really, because the earth, too, is a forge. It melts, molds, and remakes itself endlessly. And like any craftsman, it leaves fingerprints on its creations, mountains, islands, valleys, and ultimately us. We are products of this ceaseless labor, children of pressure and time. Think of the islands born from volcanoes, Hawaii, Iceland, the Azores. Places where the ocean floor cracked and the earth's molten heart poured out to form new worlds. It's astonishing, isn't it? That destruction can create paradise. That something as violent as an eruption can give birth to beaches, forests, and the laughter of generations. When a volcano erupts, it doesn't end the story. It starts another. Volcanoes have also given us warmth, not just metaphorically, but literally. Geothermal energy, drawn from the heat beneath the crust, now powers entire cities. In Iceland, homes are heated by water drawn from deep beneath volcanic rock. Hot water from the earth itself, flowing through radiators, warming living rooms, drying mittens on winter days. There's poetry in that too. The same fire that once frightened us now keeps us alive. Science, at its best, is simply friendship with what once scared us. There's a phrase I've always loved. The earth keeps no grudges. It cracks, burns, shakes, and then it cools, it heals. Even after the most catastrophic eruption, the land begins to rebuild itself. Seeds fall, rain returns, moss grows over black rock, and in time, forests rise where lava once flowed. The planet never mourns forever. It just continues. Maybe that's the quiet lesson volcanoes offer us. Resilience without bitterness. Every volcano has a memory. Layers of ash and stone record each eruption like the rings of a tree. Scientists read those layers to piece together the past. Each stratum a sentence in the autobiography of the Earth. When you think about it, we humans do the same. We layer our own histories, moment by moment, experience upon experience. Some layers are calm, some fiery, but together they make us whole. We are, all of us, walking volcanoes. Quiet most of the time, occasionally erupting, but always rebuilding ourselves afterward. And then there's the silence after an eruption, that strange, heavy calm. The sky still hazy, the ground still warm, but the roar gone. If you ever visit a volcano days after it erupts, you'll notice the stillness. It's not peaceful exactly. It's something deeper. It feels like the planet has exhaled and is resting from the effort of being alive. It's the kind of silence that doesn't ask for words. Sometimes I think the night sky mirrors that silence. Stars scattered across blackness, each one a reminder that creation and destruction are happening everywhere, all the time. A star is a volcano turned inside out. Heat and fusion instead of magma and gas. And when stars die, they scatter the same elements that make up lava, oceans, and us. We live on a planet made of exploded stars, watching smaller explosions through the lens of time. It's oddly comforting. Volcanoes also remind us that permanence is an illusion, and yet that impermanence can be beautiful. The lava that destroys a forest today will cool into obsidian tomorrow, a black glass that once served ancient humans for tools, blades, and mirrors. Even destruction has utility. Even fire leaves gifts behind. That's a gentle kind of wisdom, one we often forget in our search for control. If you've ever held a piece of volcanic rock, you know it feels light, almost fragile, full of holes formed as gas escaped during cooling. Those holes, those imperfections, are what make it float on water. It's poetic, really. The stone that survived fire can now float on a lake. Maybe we should all be so porous. Maybe the things that scar us are the same things that keep us afloat. At this hour, as the night grows heavier and the air cools, I like to imagine the world from far above. A blue sphere drifting through space, its continents lit by quiet cities, its volcanoes glowing faintly in the dark like embers. Somewhere, magma rises. Somewhere else, an island is being born. And somewhere, someone is listening to this, breathing softly, eyes heavy, learning about volcanoes, and slowly falling asleep. It's strange, isn't it? How knowledge can soothe us. How learning, something we associate with activity, with effort, can become a lullaby. But it makes sense. Because understanding removes fear, and when fear dissolves, what remains is wonder. That's the real purpose of science, not to dominate nature, but to be at peace with it. So now, as you drift, remember this. The earth beneath you is alive. It hums gently, breathes heat from its hidden heart, and turns endlessly, carrying oceans, mountains, and you through the quiet dark of space. You are safe on its surface, a small, luminous being, resting on a great, ancient body of stone and fire. And the next time you see a mountain, perhaps you'll look a little longer and feel a quiet kinship, an understanding that everything, from magma to memory, is part of the same story. The earth is old, but it still dreams. Its heart still burns. Its silence still sings. And as you close your eyes now, let that thought settle gently in your mind. The warmth, the pulse, the endless patience of the world beneath you. It waits. It changes. It endures. Just like you. Good night.